Okay, again, we will look at one kind of generic math problem and then a word problem to kind of make sense of how this formula is used, what we are doing. So on the upper right in red, I wrote a few key vocabulary words here. We could call this a logarithmic derivative or relative rate of change, or if it says percent rate of change, like this first one is asking there, percent rate of change. Same thing, it just means change it to a percent. So, like, what does all this mean? First off, a rate of change, we're saying relative rate of change. How much is it changing, right? The rate, there's the derivative compared to the original. So the rate of the increase or decrease divided by the actual price or whatever you're doing. In this example, we're doing price, so I wrote price. Okay. Now, why is it called a logarithmic derivative? It's because if you remember the derivative of a log, right, the derivative of d over dx of ln x is the derivative of x, which, for x we just get 1 over x, right? But it's derivative y prime over itself. And that's exactly what this formula is, the derivative over itself. Okay, so number one, let's switch colors here. Find the logarithmic derivative for this function f of p. So I need its derivative. Oops, can't write right now. Anyways, its derivative over itself, right? So the derivative first, I'll do it off to the side here. Let's do it in green. So I would rewrite f of p as p plus 2 to the negative 1, but you could do quotient rule if you chose. Okay, so the derivative then, we get to bring down the negative 1, multiplied by p plus 2, subtract 1, and chain rule it, but the derivative of the inside is just 1, right? So that's a negative 1 over p plus 2 squared. Or you can leave it with the negatives, up to you. All right, so rewriting this, we then have the derivative is negative 1 over p plus 2 squared over the original 1 over p plus 2. And then that is quite ugly, right? So when we divide fractions, we multiply by the reciprocal. So I would change that to this. Multiplied by p plus 2 over 1. Now notice we have p plus 2 squared, p plus 2. We could cancel one of those. So we'd have p plus 2 to the 1. And therefore we get negative 1 over p plus 2. Okay, that is the log derivative for that f of p equals 1 over p plus 2. Then part 2, or at p equals 2 and p equals 8. So at p equals 2, we'll just do it in red. So at p equals 2, we get negative 1 over 2 plus 2, right? So we get negative 1/4. At p equals 8, same thing, except for substitute 8. So 8 plus 2, so we get negative 1/10. And the percent, so here's the log derivative. Okay, the percent rate of change at those two values, I have it in a fraction, so the percent, right, just changed 1/4 is 25%, but it's negative, so negative 25%. 1/10 is 10%, but it's negative 10%. So that means at p equals 2, this thing is dropping 25%, whatever it is, right? It's a generic problem, so I don't know. But when p is increased to 8, it's only dropping 10% at that given time. All right, let's look at a more realistic problem here. The wholesale price in dollars of 1 pound of ground beef is modeled by that function. Okay, again, they probably took a whole bunch of data and put it in a computer and they got that function. So T is the years after 2010. Estimate the price in 2011 and the rate in the the change of price per year, right? There's derivative, logarithmic derivative, or relative rate of change in 2011. I'm sorry, no, that's just derivative, the change, right? The percent rate of increase here, that's our log derivative. So really A just means what is f of 1? So substitute 1 and that would approximate, right? It's modeled by, so it's approximate. The price in 2011 should be 3.08 plus 0.57 times 1 minus 0.1 times 1 squared plus 0.01 times 1 to the third. And get well, all these ones I really didn't need to write, right? Times 1 squared times 1 to the third. So really it's just 3.08 plus 0.57 minus 10 cents plus a penny, and you get 3.56 a pound. So per pound, because it tells you, right, the price in dollars of 1 pound. So 3.56, let's throw in units, dollars per pound. Okay, B. Or, I'm sorry, not B, but the second part of part A, the rate. So the rate just means derivative. So let's go ahead and do derivative. So we'd get derivative of a constant 0. Derivative of 0.57t is 0.57. Negative 1t squared is negative 0.2t. And then 0.01t the third is 0.03t squared. But then we need to plug in 1. I should have given myself a little bit of room. That's okay. So f prime of 1, again, t is 1 isn't going to change anything. So I'll just get 0.57 minus 0.2 plus 0.3. Ooh, that should be 0.03. Just realized that mistake there. Right, 0.01. So 0.03. Okay, so 0.03. Minus 0.2 plus 0.03. So 60 should be 40 cents. So the derivative is 40 cents, but that is per year, per pound, right? So per year, 40 cents a pound per year. So 1 year later, we would expect the change to be, right, the change to rise 40 cents a pound. So we'd expect it to be like $4.06. Okay. So last one, what is the percent rate of increase? So this should be kind of old skills here, but a percent rate of increase, we need the change. So in calculus notation, we need the rate, right? So the rate change was 40 cents over the original, which was 3.56, and plug that in a calculator, we get about 0.112, but it wants a percent, so that's about 11.2% when we move the decimal twice. Right, so it's always the change over the original. So the percent rate of increase, it's increasing 40 cents from the $3.56 in 2011. If we computed later, right, we may get different values.